Okay. Hello guys, welcome to another video. Now, in this video, we'll be looking at the topic which we call volcanicity, right? Now, volcanicity, right, is the process through which gases and molten rock are extruded, poured on the Earth's surface, or intruded or forced into the Earth's surface, right? Now, the molten rock that is extruded, right, um, out or poured out of this opening is what you would call lava, right? Or you could say that it's extrusive material, and when it cools and hardens, you could say that it's an extrusive rock, right? And therefore, molten rock material that are injected into the crust, right? They're called intrusive material. When it cools, it's called intrusive rock, right? And this rock material is normally called magma, right? Now, specific objectives that we'll be looking at in this video, right? So, the first being the type of material that is ejected. So basically, volcanic material. We'll be looking at the types of volcanoes, and we'll be looking at the types of magma, right? So these are the three main objectives that we'll be looking at in this video. Now I'll be going through we'll be looking at volcanic material, right? No, there are different types of materials that may erupt from an active volcano. Now, this includes the first one being lava, right? No, lava is magma that breaks the surface, right? And it erupts from a volcano, right? Now, if the magma is very fluid, right, it flows rapidly. And if it is acidic, then it would create steeper slopes, steeper volcanic slopes, right? No, you have two types of lava. And in doing lava, which is one part, which is one of the materials ejected from a volcano, I'll be looking at the types of volcanic material. Sorry, the types of lava, right? This should be lava, right? The types of lava, right? Or magma, same thing, right? It's just that lava is when it's out of the volcano, and magma is when it's inside of the volcano. Now, in looking at the material that is ejected from a volcano, we'll be looking at the types of lava. You have basic lava, and you have, I'm going to put this over here, and you have acidic lava, right? No, basic lava is the lava that would be more fluid, right? It would just run off the hill. And this is why it would create gentle sloping, right? Gentle slopes, right? Now, I'm going to be summarizing all of this information in the form of a table, right? In comparing the differences between basic lava and acidic lava. Now, the first thing about basic lava is that it has a high amount of silica, right? comparing acidic lava, wait, I'm sorry, low amounts of silica. My bad. I'm going to erase this right here. It's not high amounts of silica, it's low amounts of silica, right? That was a mistake. Good. That was a mistake, right? So this contains low amounts of silica. Yeah. Good. This contains high amounts of silica. No, because basic lava contains low amounts of silica, then it would tend to be more fluid. So it's highly fluid. Because this contains a large amount of silica, then it would be highly viscous. Now, viscous is the term we use in geography to when we are saying thick. So anytime we mean to say thick in geography, we would say viscous, right? So it's highly viscous, or you could say it's sticky, right? The thing with basic lava now, it has a low melting point. Meanwhile, for acidic lava, it has a high melting point. All right, I'll put point right here. Good. Now, with basic lava now, it would travel long distances. Right? Because of course of how it's highly fluid, right? Meanwhile, for acidic lava, because of how viscous it is, all right, and it would seldom travel far, meaning that it would not travel long distances, right? Good. For basic lava now, it would create gentle slopes. So gentle slopes, right? Gentle slopes. And for acidic lava, it would be steep slopes. Now, why would this be so? All right? Why would this be so? Why would basic lava create gentle slopes and acidic lava create steep slopes? No. The reason for this is that basic lava, because it's highly fluid and because it has low amounts of silica, therefore it would not be thick, it would be runny, right? So instead of the lava getting to cool and harden, it would quickly run off the surface of the volcano. Therefore, it would harden and cool elsewhere. It would not. It would be hard to harden and cool. It would be hard to cool because of how fluid it is. Right? It wouldn't be one at one place, so that it could be able to cool, right? So it would be very hard to cool. In comparison to acidic lava it doesn't travel far. It's very slow, right? So therefore, it would harden and cool very easily, right? And because it hardens and cools, then it would create a layer, right, on top by the volcanic slope. Because of these continuous layers now, then you will create a steep slope, right? Now, we're going to be looking at volcanic material, right? And we're still looking at volcanic material, and we're looking at tephra and volcanic, tephra and pyroclastic material, right? Now this has two components, right? Four components, I should say, right? The first one being pumice, right? Now, pumice is this light colored frothy volcanic rock, and it's normally formed by the expansion of gas in erupting lava. So just like how you bake a cake and you would put baking soda or baking powder as a raising agent, that allows the carbon dioxide made in the cake to basically expand so that the cake would rise, right? Same thing. Well, the same thing applies, right? So these are basically frothy rocks in which gases expand. So when you look at the rock, it looks as if it's froth, but it's actually a rock. The next one that we're going to look at is cinders. Now, cinders, these are very vesicular, right? They have small cell or cavity, and they are normally lava fragments. So basically, they are these small fragments of rock, right? So basically, they would look like, extremely small pebbles, extremely small, right? Good. Now, the next one that we're going to look at is volcanic ash, right? Now, these are very small particles, right? Fine particles of pulverized rock blown from the explosion vent. So they're very small. Basically, they're dust, right? They're basically dust. The next one that we're going to look at is volcanic bombs, right? Volcanic bombs. And this is a mass of molten rock, right? So it's normally larger than 3 inches or larger than 2 inches, right? So it ranges from maybe the size of your finger to a car, right? So the size varies. The size of volcanic bombs, it varies, right? Now, you have gases, right? So we looked at Tyra. So first we look at the materials ejected from a volcano. So first we look at lava. Then we look at tephra and pyroclastic material. Now we are going to be looking at gases. Now, of course, we would expect that gases would eject from a volcano, provided that it comes from inside of the earth, right? So primarily, the gases are ejected in the form of steam, right? And the gases that are normally ejected include sulfur dioxide, carbon carbon dioxide, water vapor in the form of steam, of course, and you would have chlorine and fluorine gases, right? So chlorine and fluorine gases, right? So these are the gases that are ejected from a volcano, right? Now, we finished looking at the types of lava, the types of the materials ejected. Now we're going to be looking at the types of volcanoes. Now, firstly, a volcano is what we call an opening or a rupture in the Earth's crust or in the Earth's surface, and it allows hot molten rock, ash, and the gases to escape from deep below the surface. So now we're going to be looking at the types of volcanoes. Now you have three types of volcanoes. You have active, right? So the first one is active. We'll be looking at active. Now, active volcanoes, right? Now, this is a volcano that has erupted within the last 500 years, right? And it still shows sign of activity, right? So meaning that you would expect to erupt at any time. Then you have the next one, it's dormant. Now, dormant volcanoes, they haven't erupted within the last 500 years. However, it still shows sign of activity. And an example of this is Mount Kilimanjaro, right? Because Mount Kilimanjaro has hot springs and stuff. In the form of hot springs, you have geysers, the different features of volcanoes, right? Then you have extinct. Extinct volcanoes, right? These volcanoes, they have not erupted within the last 500 years. However, they do not show sign of activity. And an example of this is Mount Kenya, right? Now, this is the end of our video. In the next video, I'll be looking at the different parts of the volcano. I'll be looking at the features of a volcano, right? And that's it for today. Please like, subscribe, and thank you for watching.